All right, thank you very much, everyone. I hope you can all hear me. So let me just start off with a quick presentation. So basically, what I'm going to show you is a functionality we added to support summary statistics from genome-wide association studies. And just very briefly, I know most of you probably are aware of this, but put the general definition of a GWAS from Wikipedia. Basically, GWASs look at allelic differences between cohorts, and typically with one cohort expressing a trait of interest versus another cohort that does not express that trait. And what the result of these are sets of p-values associated with variations, typically single nucleotide polymorphisms. And what we load into tranSMART is summary statistics. Another very useful way of examining these data is the use of a so-called Manhattan plot, and there's a picture of one here, again out of Wikipedia, where the genome is, or chromosomal regions, are on the x-axis, and the p-values, in this case the negative log p, is on the y-axis. And in this case, there may be some real interest. I don't know what this study is, but some real interest. We're seeing some significant SNPs in chromosome 6. Oops, I'm trying to advance my, there it goes, advance my slide deck. So basically, a couple of years ago, our customer groups, particularly our precision medicine researchers, had come to us with a high interest in taking in GWAS sets and having a centralized system to store them. Some of these GWAS sets come from the public domain or from collaborations, and we have several sets that are proprietary to Pfizer. And we had to determine whether or not we built the system ourselves and used a Manhattan plot viewer such as Locusum, which I believe actually came out of Brian's group in University of Michigan, or if we use an existing tool set. What we decided to do, because there wasn't very many commercial options for us, we decided to build this into tranSMART, and we worked with Converge Health to make that happen. We've done 2 rounds of development, and we leveraged the faceted search capability within tranSMART, and we also built a fit client for displaying Manhattan plots interactively, and that's called GWAS, a Genome-Wide Association Variant Analyzer. And I'll demo a bit of the faceted search capability within tranSMART 1.2 as well as GWAS. So basically, these data are essentially used for target selection. And the response from our user groups is that it is saving them a substantial amount of time when pulling together human genetics information to associate with other elements for determining what targets to select for drug programs. Currently, we have about over 500 GWAS analysis represented in tranSMART, and over 300 have 8 million SNPs associated with them. So basically, it's a million SNP chip imputed to approximately 8 million. We've used these across multiple Pfizer research units, and we also support expression quantitative trait loci as well as metabolomic associations. So very quickly, here are some of the contributors, and there's quite a number. I really want to call out Converge Health for doing the development, working with us, and there are a number of people who were really important to making these features a reality. And secondly, I want to call up some specific people within Pfizer. Ami Kandeshi was our tech lead, who worked very closely with Converge Health to lead the development effort. Ami left the company relatively recently, and Hugo Berube has now taken over the technical lead, and Hugo and Hyan have really done a lot of work over the last month making sure that the GWAS functionality actually works within 1.2. And I want to highlight Peter Henstock, who built GWAS. So Peter is one of our biostatisticians. He's actually a very, very good programmer and loves to program interfaces. And the fit client that you'll see is actually all his work. Okay, so I'll bring up tranSMART. Okay, so basically there's a new tab within tranSMART labeled GWAS, And basically on the left-hand side is a filter browser that you can use to filter various analyses that are presented on the right-hand side of the panel. So for example, I'll do just a couple very quick filterings. So if I go to study, I can get all the studies that are listed. In this case, the magic set, the so-called magic set, is a set of a few analyses that are publicly available GWAS sets. And I can select those, and I can filter based on the study name. Within this study, there are 5 analyses, 5 individual GWAS analyses. And if I want to further restrict, I can do so from the analyses selection, or I can very simply, I want to see the fasting glucose and fasting insulin. I can add the select the filter, and interestingly enough, there's a bug. I haven't seen that before. Great. Yeah, the demo gods are, I'm going to try that again. All right. Interesting. All right, so there's a bug we'll have to correct. But basically, when you open up any of these, so I'll open up the fasting insulin, what you'll see first and foremost is the 500 most significant SNPs in tabular format. And basically, there are a number of attributes associated with each individual SNP. Of course, all of them will have, by necessity, will have the negative log p-value, the p-value and the negative log p-value, and the position within the chromosome. And if they are within a gene area, it'll list that gene and whether or not it's in an intron or exon. The regular score will be available, as well as a number of other metrics that can be associated, may or may not be associated with the individual GWAS set, and of course the alleles. All right. So basically, what you can do to get the Manhattan plot visualization of any of these sets is simply select a set, click Manhattan plot. So I've pre-generated, it takes a few seconds to pull the Manhattan plot up. It's a Java WebStar application. But I've already done that. And basically what you're seeing in this interface called GWAS is the list of available models that we saw within tranSMART, and you can select any of these models for inclusion, one or many. You can put in a list of genes or RSIDs, and then you can run the analysis, and it will pull back that chromosomal region and the SNPs that are associated with it. So in this case, I'll put in one and start. I'll put in PCSK9. And for this particular model, and I'll click Retrieve Data, and we'll start the process. Now, I've already pulled back a few, and I can show you, in this case, G6PC2 was one of the more significant SNPs in the fasting glucose model. And if I click that, click on Color Plot, and I'll get the Manhattan plot with all the genes noted and annotated on the chromosomal axis and the negative log p-value. I can mouse over and get any information associated with the individual SNP. I can identify gene areas pretty easily. I can also, by my right mouse clicking, go to that region within the UCSC browser. I can add lines for significance. So in this case, this is a meta-analysis, which some of you are wondering why the negative log p-values are so significant. But basically, I can put in, see a line anywhere, I'll call it my line, and identify, just to help identify where my cutoff for significance might be. I can make a printer-ready format, or more pretty format for printing. And if I have models that are within the same chromosomal region, I can select 2, put it on the color plot, and I can have multiple analyses overlaid. If, in this case, I have two regions, another region, this AKNAD1, you can, in this case, if there's data, I'll see the recombination rate. This is what this light colored line is. Go back to the regular format. And I can also look at trellis plots. So if I can overlay plots on the Manhattan visualization if they're within the same chromosomal region. I cannot do that if they're across two different regions. So if I try to do that, it'll give me an error. But what I can do, if I select these two, I can go to a thumbnail plot. And basically in this thumbnail plot, the y-axis, the negative log p, is normalized. And I can look at the models in this view. And although they vary in their chromosomal region, they're normalized by significance. And I can play around with the visualization. All right. And one last thing that I'll show you is a table view. So basically, if I want to slice and dice the actual data, I can include it, either all the data or for the selected models. I can bring that in. I can do things like if I want to put a cutoff for the p-value, say at 5, I can remove everything that is greater than, in this case, less than a negative log p-value of 5. I can very easily slice and dice, export the data from this interface. So between tranSMART and this thick client genome-wide association viewer, we have a really, really nice packet of tools for being able to view and store our summary statistics for these types of studies. And I'll leave it there. Thank you very much.